So let's start the motion, that is of what happened. Move this window, this shaded portion, and meeting all. Hmm. See, this is the curvilinear motion. Okay, so under curvilinear motion means in the previous one you already seen there that for the means when a particle is here and that particle move straight away. Please mute yourself. Now for the curvilinear motion, actually if we consider a coordinate system, if we what happened. If we consider a coordinate, and in that coordinate if we consider one position vector of any particle, suppose that particle is denoted as p, okay, and that is at a r vector. At a r vector means the coordinate of that particle, and if that particle move in such a manner in this direction, okay, means the new position of that particle is suppose this one p dash. Clear? It move following this path. This is not a straight path, right? Now if you consider this one as a r vector dash, and this movement of this particle considered as a del r, okay, means from this coordinate, position coordinate, this is a position coordinate. You all know that how to in a space how to define a position vector in the statics very first lecture we have already discussed about that. So this position vector in the space. So from this point to this point mean r dash bar minus r dash vector is nothing but we define it as a del r vector, okay. Now if a particle move in that direction, and this in means this change in this position, if it will take del t time, okay, then what is should be the velocity, what should be the instantaneous velocity? Instantaneous velocity should be limit, you all know for instantaneous velocity means time should be tends to 0. So instantaneous velocity is nothing but del r vector by del t, okay. Or we can define this thing as a, instead of del, write dr by dt, okay. This is our instantaneous velocity. Now the average speed, so it is a velocity. Now if we want to find out what should be the average speed, so average speed we can write average speed. For average speed is nothing but the displacement, amount of displacement with that specific interval, right? It means it follows a path. See, this is a particle, this particle p following a path na? This is the path actually. So this length, this arc means path length, means this is if it is one position, this is one position, and if this is the path, then the length of this path is the displacement amount, right? So del s, so the del s divided by del t. Clear? Now uh, so in the similar manner we can find out the acceleration also. For acceleration, what should be that? That should be, means in a similar manner na, right? Here see, this is your coordinate, this is your position vector of this particle, and if this is your curve, suppose your curve is like that, suppose, huh? Means this curvilinear motion na. So always remember your velocity always tangent to that curve. Okay, so that is the vector, and always perpendicular the of the trajectory, we can say. So that is your acceleration of that particle. So always remember that the velocity is the tangent of that path and acceleration is perpendicular to that one. Okay, so this is one. Now uh, suppose a vector u, hmm, we can write here in such a manner that suppose this is your this is your vector. Hmm. Consider this p vector na, where u is the scalar. Remember, u is scalar, means only magnitude, huh? So if p is a vector, and if u varies the particle, how it can vary, how we can vary the u, means the particle move along the path, and the tip of that vector p is going to be move, as well as length of the p is change. Understand? Means if it is a motion is like in such a manner that this distance, and suppose after certain time it will go in this position, so this distance there's a change, means they have a different magnitude, as well as the direction also change. So it means when that, so it means when that u varies, as well as the vector p also vary, because it move na, this particle move. So for a specific interval we can write this thing as a dp vector by dt, which is nothing but del t tends to 0. Here you can say that if it is p at interval of 0, means at a starting position, if we write it is pu, and after certain time we can write it, we can easily write p plus del u, right? After del t interval, so p u plus del u minus p, sorry, minus p u divided by del t. Okay, or we can write here del u, because initial minus final by initial, this is t. Okay, so this vector is the tangent of that path, means this is your displacement divided by the time, so that is your tangential portion, that is a velocity. Okay, so up to this, anyone have any question? So what one is, we already just go through that. One is the change in displacement, that is one velocity, and if time tends to 0, then that is the instantaneous velocity. Then another thing is the average speed, means that path length divided by time interval. Another one is the derivative of velocity, we get the acceleration. Up to this, is it clear, right? Up to this, anyone have any query? Please reply anyone. If query, then you can ask, no issue. Hello students, is my voice audible?
Yes, sir.
Up to this, is it clear? Up to this?
Okay, sir.
Okay. So next part is, see, next part is the tangential and normal components. So here, this is actually tangential and normal component. So we can say if a coordinate is like that, and if a particle, suppose this is a particle, move along a circular manner, or means continuously changing its position, so we can say that the tangential portion is nothing but the velocity, right? So here we have to, means tangential and the normal components, or we can say the coordinate, we can define this as a, one is tangential unit vector, that is a et, and one is the normal, which is along the radial direction, so it is the er. So one, sorry, en, one is en, another one is the et. Okay, so en is the normal, which is perpendicular direction of et. Here you can see this is your 90 degree, so it is the normal and perpendicular direction. Now if it change a very small amount, here it create a angle, that is d theta, right? So this position, this position to this position, it will change d theta amount, right? So en into d theta is equal to et, right? We can say this is a very small, so d et we can write. Is it clear? And if that velocity vector is defined as along x vxi plus along y x y of j plus v of z k unit vector. Okay, if it is like that, then we can write that v, v is a vector, is nothing but v into, this is the magnitude of that vector, into unit vector et, et. Okay, that is called the tangential component, which is along the velocity, along the direction of velocity. Similarly, if it is v and et unit vector, then acceleration, acceleration is d v vector by dt, right? So it is nothing but d dt of v dot et unit vector, and a is so nothing but dv by dt. Here v is not a vector, remember, this is a vector, but this is a magnitude into et, means simply we use that derivative formula for product, any product case, and that is v into det unit vector by dt. Up to this, anyone have any confusion? You can ask. Is it clear up to this? Please reply. Up to this, is it clear?
Okay, sir.
Any question you can ask, no issue. Please reply anyone. My
Yes,
voice
sir.
is audible, right? So shall I continue? Means up to this, is it clear?
Yes, sir.
Okay. So see here, this is the acceleration vector, and this is nothing but the, we use the formula and we can get this one, na? Derivative of these two. Now, as det and means this portion det by dt is not zero. Why it is not zero? Because it is in this curve, it continuously changing, na? In a curve, that et unit vector is continuously changing its direction, so it is not a zero. It is not zero. Okay, if it is not zero, then we can easily write that det unit vector by dt is v by rho en. This is actually a formula. How it will come? Okay, now we will discuss that one, how it will come. See, det by t is equals to det, change in the direction of theta, right? So it means theta into d theta by ds with respect to its position, displacement, and ds by dt. We can write this thing as this one. Now this det by dt, we can write det by d theta. This is what? This is nothing but the, here, this one, det by d theta is nothing but the unit vector of en, na? So we can write here en unit vector, and this d theta by ds is what? This d theta by ds is this radius, so we can define as a 1 by rho, and this ds by dt is nothing but the change in displacement, is velocity. Okay, so it is nothing but v by rho of en. Okay, so det by dt is equal to v by rho en. Up to this, is it clear? Then a is nothing but v by dt et plus v into v by rho into en. So from this equation, we can say acceleration have two component, right? One is what? Change in speed, means this one change in speed, and another one component, that is the angular rate, this v by rho angular rate change. Hmm. And we can say this thing as a at, means if we write in such a manner that a vector is nothing but in two form, not tangential and normal. So tangential into et unit vector plus normal into unit vector. So this at is nothing but the dv by dt, and this an is nothing but the, sorry, v square by rho. So up to this, anyone have any question? V square by rho. Up to this, is it clear, student, or anyone have any question? You can ask. This is actually the first time for you, so that's why I am very slowly just try to understandable, means this lecture, so that you can easily can understand this thing. If anyone have any question, you can ask. That's sir, what is this? What is that one? You can ask. No issue. So up to this, is it clear, student? Hello, please reply anyone. Student, is my voice audible? Are you there? Okay, I shall continue. Suppose here I already told you that an is a component. An is a component, that is v square by rho, right? So in this v square by rho, actually this is for the curvilinear motion. Okay. Now, if it is this for any particle, suppose for any particle that goes straight, then what happened with this portion? This is simply is equal to 0 in that case. Okay. Now another coordinate system is there, that is called the radial and transverse component. Okay. Here what happened in the previous one means the tangential and normal component, we can see that any coordinate system and particle change its position as well as the orientation, right? Now if a particle is like here, in this coordinate is at a space vector defined as r, its position, and if this particle move in such a manner that along the tangent have its velocity along the normal, means in the same direction it's have the acceleration, then what happened? So remember here have two component, one is in the previous one we have two component, one is en normal unit vector and the tangential, right? En and et, here it is en and et, right? And here it is, one is radial er and one is transverse, that is e theta. Okay, these two are there. So r vector, r is a position vector, so r vector is nothing but unit, means its magnitude r into unit vector. Clear? It is the same direction. And this is the defined as a position r vector here, this position of that particle p. And what is the velocity? How we can define the velocity? It is nothing but the derivative of this position vector. So we can find out that it is nothing but the ddt of r er plus r der of dt, means simply derivative of these two. And as this der by dt, this portion is what? This portion is simply, we can write e theta. Okay, this is also similar manner, you can just solve how to come this one, same thing. And this de theta by dt is nothing but minus of theta of er. So we can get the velocity vector is nothing but r dot means derivative er plus r theta dot e theta. So this is the another formula to find out the velocity of any means using the radial and transverse coordinate, or you can say this is the polar coordinate. Okay, and the acceleration, it is the velocity, so dv vector by dt is nothing but the acceleration. So this acceleration, if you just derivative this thing, you can find out r double dot minus r theta dot square of er plus r theta double dot plus 2r dot theta dot e theta. So these are the acceleration. These two formula you have to remember, and similarly here you have to remember these two formula, that is the dv by dt of et component and v by rho, that is the angular rate, and this det by dt is equal to v by rho of en. So this thing you have to remember. Okay, so up to this, anyone have any question? You can raise your question, student. Today what we have learned, that is one is the tangential and normal component, one is the radial and the transverse coordinate, right? So remember one thing, for any coordinate system, if it is, suppose rectangular coordinate, suppose it is a rectangular coordinate system, we define as a x, y and z. Similarly, when it is any cylindrical coordinate, then we define as a r theta and z. And for spherical coordinate, we define as a r theta and phi. Okay, these are the basic coordinate, means choice of coordinates are like that. So now we shall start a numerical problem based on this formulae, and which is also in the part of our dynamics. Okay, so up to this, have you already written now all the thing? Because now need that formula actually to solve any types of problem. Okay, suppose, what happened? Okay, uh, before start one numerical, let's give one short topic, that is actually, if this is, you already seen that one particle to another position means particle displacement or movement, means linear, one is the curvilinear na? Now another case is the, if that particle move in the circular way, then what happened? It's very simple. When it move in the circular, then the velocity is nothing but the r theta dot. Theta dot means the derivative, na? And here, this is actually the special case of this, na? This is also curve. This is also your curve, but it is a closed curve. So this is a special case of curvilinear motion. So here, actually, an is normally what? An is normally v square by r, na? Here you can see there. Here, an an is defined as a v square by rho. Rho means the radius, so v square by r. So as v is how much? V is the radius into derivative of the angle, means the change in the angular position, and the radius is the velocity. right? Or we can say, means yeah, in class 11 12 you can already go through that v is equal to omega r. So that omega is the change in the displacement, that is here denoted as theta dot. Okay, so r theta dot square by r. So how, what it will come? It will simply come as v into theta dot. Okay, same thing. Now one is a t, tangential component of that acceleration is the v dot, so r theta double dot. Okay, these two are, you have to remember for circular motion. Okay, up to this anyone have any question, student? Please reply. If anyone have any question, you can reply. Okay, then now we shall start one problem on this curvilinear motion. Okay, see, so the question is like that: any curvilinear motion of a particle, if it is defined as, suppose Vx component is defined as a time, means there all are the equation, in terms of equation they are giving the motion. Okay, where v is v, this one vx is in the meter per second and y is in meter. Okay, now another thing is given that at x is equal to 0, when time is equal to 0, at time a, at time is equal to 0 means initial condition x is also 0. So the question is plot the path of the particle. One is need to find out, plot the path of the particle, and to determine its velocity and acceleration when the position y is 0, when y is equal to 0. So how to start, how to solve this type of problem? This is quite simple type actually. You can simply write here as we know v is equal to dx by dt, and 0 to x dx is nothing but 0 to t, and v is how much it is given, 50 minus 16t, right? So x is nothing but 50t minus 8t square, right? This will come, this is meter. Hmm. And after that what we have to do, simply put ax is nothing but dx dot, means derivative, so it means derivative of 50t minus how much, how much it is, 50t, sorry it is given here 50 minus 16, sorry, minus 16t. So it will come minus 16 meter per second square. Okay, now y component of velocity and acceleration, Y component of that velocity and acceleration is Vy is nothing but y dot, and here y dot means what? Simply y dot means ddt of y is how much? 100 minus 4 t square, it is given in question. So it is nothing but the 80 t meter per second. And acceleration is how much? Acceleration is uh, we can say simply Vy dot. So we can get ddt of minus 8 of t, it is minus 8 meter per second square. Okay, so if it is now, as per question, it is said for y is equal to 0, we have to find out the velocity and acceleration, right? So for y is equal to 0, if we put, then we get y is equal to 0 is equal to 100 minus 40 t square, nothing but t is equal to how much? If it is, then how much it will come? Sorry, not 4, no, this is 100 root over of by 4, so 5 second. Okay, now see, for this value of time, Vx is how much? 50 minus 16t, and t is here 5. So how much it is? Minus 30 meter per second, right? So acceleration is how much? Acceleration is root over of minus 16 square plus 8 square. It is 17.9 meter per second square. It will come. Why? This is like because 16 minus 16 is the ax component, ax, and this one is the ay, along x and along y. See, this is your minus 16 and this is your ay is minus 8. So up to this, anyone have any question now in this math? This is a one curvilinear motion based problem. Okay, anyone have any question up to this? Please reply, student. Hello, is there anyone? Please reply.
So once explain again, sir.
Which one? Please tell. Means this problem from the beginning.
Problem, sir.
Okay, okay. See, here in the problem actually, they ask that if, means what are the given thing? The given thing is the velocity is given as this in such equation, and the displacement is given in such equation. Okay, so if it is like that, then question said draw a plot, or you can simply find out the velocity and the acceleration for the position of that particle, that is y is equal to 0. It is given in the question that, see here, y is equal to 100 minus 40 square, right? This is given in the question. When y is equal to 0, in that condition, find out the velocity and acceleration. That is the question. So how to solve? Now we know that velocity is given, so v is nothing but the dx by dt, and means displacement by time. So if it is dx by dt, then we simply just integrate that and find out the equation for displacement, okay, from the velocity. So dx by dt, just if we integrate, then we find out the displacement. Now acceleration is what? Acceleration is derivative of that velocity, and this is the displacement, this one, and this one is the acceleration. Acceleration is the derivative of that velocity, so we just derivative of that part, and derivative of that part means velocity, it is given 50 minus 16t, so we just simply derivative this one. Now question, it said that y component means y is equal to 100 minus 40 square na. So y component of the velocity is how we can define, we can define vy, y direction, so derivative of velocity, and means y is given what, y is given as, y is a displacement and the velocity is a derivative of the displacement, so y is given as 100 minus 40 square, so derivative of that is the velocity in y direction, right? So it is nothing but the minus 80. Now acceleration also derivative of velocity, so derivative of this portion derivative, so it will come minus 8. So along y direction, both the velocity and the acceleration we get, right? If it is, then as per question, it is given that for y is equal to 0, what should be the acceleration velocity? So put y is equal to 0, and this is from here we get after 5 seconds of moving any particle, we get y is equal to 0, right? So if it is, then in within that 5 seconds, how much the velocity and acceleration is? So velocity is given at 50 minus 16t, so 50 minus 16 into t is given, means we can find out 5, so just put there, so it indicates that velocity is a negative here, right? Negative velocity. And the acceleration is how much? Acceleration is 17.9, and remember this is a negative velocity, so this acceleration is also, it is one type of negative, so we can say it is a deceleration, means after 5 second with this amount of negative velocity indicates these are, means any particle moving in the directions is a slow na? It will become a slow to slower, so with this amount of deceleration, if this is your curve, then with this amount of deceleration it will come to 0, means rest position, means y is equal to 0 after 5 seconds as per our calculation. So up to this, is it clear now? This is the question actually, so is it clear? Please reply anyone at least. It means whether confusion anyone have, you can ask. So is it clear now? Student, please reply. So I think you can understand now, na? Okay. So I have to start another topic, but it will not end today. So it is better to start tomorrow, and some numerical problem we will solve after that. Okay. So here I end my lecture here. So thank you. Okay. Anyone give something? Sir, share the this written class in group. Written class in group means what? Means what I written here. Uh, One thing is possible actually. All the class what I have taken, na, I recorded all the classes actually. So if you want, I can give the that recorded video to all of you. So is that okay? Okay, okay, okay. I will share then the link. Okay, thank you.